All right, everyone, so this is the second part of your video lesson for Unit 2.2. This is function notation. So this goes along with the idea of functions, relations, one-to-one. Okay, but this is more calculating than just analyzing representations. So function notation is read f of x. So this means that x represents all of your domain, your x values, and f of x is your range. Okay, so we can think of this as y equals f of x. So when you see an equation, y equals is the same thing as f of x. And when we use f of x instead of y, that means that this is a function, and that for each x value that we input, we will get out one y value. Okay, so the way that we evaluate this, whatever is shown on the inside of the parentheses, that is our x value. Okay, so all of these problems are relating to function notation, f of x. So we can see that 2 is in place of the x. So that means x equals 2. So we're going to use x equals 2 and this given function, and we're going to evaluate. Okay, so the way that we do that using proper notation, f of 2 equals, and anywhere in this expression that you see an x, you're going to plug it in for a 2. Okay, and now we just evaluate. So f of 2 equals -1. Okay, another way that we could write a final answer for this, the x value is 2 and the y value is -1. So we could also write this as an ordered pair. This is just another notation, another way to write our information. Okay, let's try another example. So in part B, since the -3 is on the inside of the parentheses, that means that x equals -3. So what we're going to do to evaluate, anywhere in our function that we see an x, we're going to plug in -3. Okay, and then we can evaluate. Okay, so this means f of -3 equals 19. Okay, one more of this kind. So whatever's on the inside is your x. All right, so instead of a number this time, we're going to be plugging in a variable. We're plugging in m. So anywhere in our function that we see an x, we're going to replace it with m. Okay, and then we just do some simplifying. So f of m is -4m plus 7. Okay, remember, whatever's on the inside is your x value, that's getting inputted, and whatever comes out is the y. Okay, so same idea, we have some values on the inside of our function notation, but now we're going to be doing some extra operations on the outside. Okay, so each of these is going to be a multi-step problem. So for part A, the first thing that we're going to do, okay, step number 1, would be to evaluate f of -3. And we see that our f of x, our function, is a different equation this time. Okay, so we're going to plug -3 into our function anywhere that we see an x. And we want to make sure that we use parentheses, okay, especially when our value is negative, so that we get the correct signs. Okay, so when I evaluate this, okay, I have 32. All right, now step number 2 of this is going to be to take f of -3 and add 1 to it. Well, my f of -3 equals 32, and then I'm going to add 1. Okay, so my final answer here is 33. Okay, let's try that again. So part B, again, a 2-step problem. The first thing we're going to do is evaluate f of 5. Okay, and in order to evaluate that, we replace the x. Okay, make sure that you're replacing the x. And then we're going to evaluate. Okay, so 5 squared is 25, times 2 is 50, minus 15 plus 5. Okay, we get that f of 5 is 40. Now step number 2 is going to be 6 minus that value of f of 5. So it's 6 minus 40. Okay, watch your signs. Our final answer should be -34. Okay, very last one. So part C, 2 steps again. So my first step is going to be to evaluate f of -1. So we're replacing the x value. Okay, replace that with -1. And we get 10. Part 2 is going to be to evaluate f of 2. Okay, so we plug in 2 everywhere. Okay, and we get 7. Alright, and now our third step. F of -1 plus f of 2. So the value for f of -1 was 10, and the value for f of 2 was 7. So that makes my final answer 17. Okay, so 10 and 7 are not part of your final answer. They were just the work that went in to getting you there. Okay, so same idea. Again, we're just switching up the operations here. So part A, first thing I'm going to do is evaluate f of 6. Okay, and every time we want to show our work, we want to show what we're substituting in. Okay, set everything up. We want to use the proper notation, f of 6. Okay, and now these brackets on the outside here, they're telling me to multiply 3 by whatever value I got for f of 6, which was 11. So that means that my final answer is 33. Okay, now part B, we're plugging in an expression. So instead of a number, we saw this before. Okay, so f of x plus 2, anywhere that we see x, we're going to replace it with an x plus 2. Okay, this is going to mean I have to distribute. So I get 3x plus 6, bring over the 7, and now I'm going to combine like terms. So my final answer here, f of x plus 2 would be 3x minus 1. Okay, same idea in part C. Instead of evaluating at a number, we're using a variable. And this one's going to be multi-step again. Okay, so I'm going to do f of m first. Okay, and then order of operations, I'm going to multiply by 3. Okay, which means I'm going to distribute. And then lastly, add 4. Okay, so I have like terms that I want to combine there. Okay, so that last step makes up my final answer. So no matter what is on the inside of your function notation, you are replacing it in your equation. Okay, the last thing that we're going to look at is just kind of a different representation here. So we're still evaluating and we're still associating with x and y, but instead of using f of x, we sometimes are given different symbols. So this is telling me that 2 smiley face 7 corresponds to x smiley face y, and there's an equation that goes along with it. So think of x smiley face y as your function notation, and think of 5x plus y squared as your equation. So if we have 2 smiley 7, that means the 2 corresponds to the x value and the 7 corresponds to the y. So anywhere in my equation of 5x plus y squared, I'm going to replace the x value with a 2 and the y value with a 7. So 2 smiley 7, 5 times 2 plus 7 squared. So 2 smiley 7 would equal 59. Okay, and the same thing with our second example. -2 snowflake -5 corresponds to x snowflake y. And here is our equation. So we're going to replace our x value with a -2 and our y value with a -5. Okay, so evaluating we would have a -36. All right, so that is everything for function notation and application problems. Please make sure that your notes for this are complete and you write down any questions that you have.